Hey! Just started the stream and I see that we have 0 viewers because I just started. So we'll wait for everyone to join. So I'll just use this time. There's no one currently viewing, but this will be recorded, so you'll see it later. What we're going to be doing here is kind of building out the material on the fly. So I'm going to be taking some notes in Microsoft Word. In fact, let's get that a little test here. Okay, so right now, there we go. I'm sharing out the window for the Word document that kind of breaks down what we're going to be talking about. As we go throughout the day, I'm just going to be filling this bad boy out. So let's just wait for people to join. Well, yeah, I don't want to just complain. There's one viewer. Hey, what's going on? I'm going to start gathering some links and such while we wait for everyone to pop on here. Let's see, let's go to Tried But True Amazon. We're going to be covering topics that are in 2 particular texts. And while I did not require the texts, I will put links to them so you can grab them later. Let's see. Resources section in my notes here, and there's one. And I will mention this when everyone's on, but if you happen to have a Books 24/7 account, the 2 texts I'm going to reference, which are over there on my shelf, are available for free if you have that account. I'm not sure if Fullerton offers access to that. Through my alma mater, I still have access. I don't know why they didn't cut it off, but I have it, so that's cool. So we have 4 viewers. If you look over to, wrong way, that way, over to the right of your window, you'll notice that you have a chat group. In fact, you may need to hover over the left-hand side of the screen and click where it says chat. That'll enable the chat window, and if you could, those of you that are currently viewing, if you could just simply pop in your name or say hi or something so that I know that you're currently there and can at least hear me. That'd be cool. Once again, if you just go to the top left-hand side, right there on my screen, you click on the little chat icon. Looks like a little instant message bubble, if you will. You'll then get the group chat screen, and over on the right-hand side, you can then chat. So try that. All right, we have nearly 20 people signed up, and there's 4 viewers now, so we're just going to hang out here. And I don't want to divulge too much without everyone being here. Look around for stuff to play with. Might as well talk about this book for now. This particular text, Practical Packet Analysis, it's by No Starch Press. They make some phenomenal books. I got to go to one of their parties at DEF CON recently, and I was just walking around meeting all the authors. I was like, oh, that's cool. I like your books. So this particular text, it is available on Books 24/7 if you have a 24/7 account. If not, if you pick it up on Amazon, it's like $35 or something like that. Pretty much everything we're going to cover today is in this book. Let me rephrase that. Everything we're going to cover regarding Wireshark is in this book. However, the purpose of today is not to go over a textbook, but rather I'm going to just use Google. I'm going to pull up some Wikipedia references. In fact, Wireshark's online manual is more than thorough. In fact, this book is pretty much just a synthesized version of the online manual. So we're going to be relying on that. This book's just kind of out there as an additional resource if you're so interested. Fix my red shirt there. There we go. No one's chatting yet. So for the three of you that can hopefully hear me, we do have 2 hours scheduled. And the purpose of scheduling for 2 hours is A, dealing with what we're dealing with right now. I'm looking at 4 viewers and we have about 20 signed up. So we're going to wait for as many people can to join. And then the bulk of the time really is going to be just we're going to build out the material on the fly. And the reason for doing that is fairly simple. I want to show you guys that you don't necessarily need a bookshelf full of books when you're in the field, or at least when you're working a case. You also don't need, 1,000-page or 1,000-slide PowerPoints. You don't need dissertation papers. You need that as a foundation. Some people say you don't need education. I'm not one of those people. I have my grad degree. I'm really big into education, lifelong learning. You need to read the books, you need to hit the books, but when you're working a case, you're not going to pull out a textbook most of the time and parse through it, but rather you're just going to take that knowledge and you're going to further, you're going to use critical thinking and analytical skills, and you're going to look on Google. You need Google. It's very, very important. It's vital these days. So what we're going to focus on is using let's see here. Looks like there's some problems with the chat. Go take a look. Some people are accessing the video directly through YouTube and thus do not have the ability to chat. I'm assuming this is one of you. Let's answer it. Hello? Oh, you don't want to talk? Alright. Yeah, so for those of you that are joined directly through YouTube, you will not be able to chat. Let me see what my link looks like. Do over. Hello? Yeah, this is Ryan. How's it going? Yeah. Oh, well, that's fine. So when you try to chat something, does it give you an error, or? Hmm? I think some students are viewing it directly live through YouTube, so you're not going to have that functionality. But when you access it directly through Google Hangouts, if you go to plus.google.com and then click on Hangouts, you should see the invite. But that's only, of course, if you have a Google account that you tied and joined from. So, that's fine. We don't need the chat. Gotcha. I think next session we'll spin up some type of conference line or something so we can just chat externally then. Okay. All right. See ya. All right, so I only see 2 viewers via this channel, but it might just be that more of you are using YouTube than I thought. So let's go back over there. Again, this is why we have about an hour and a half of content, but we scheduled out 2 hours for this type of thing right here, because this happens every time. I wonder if anyone's actually connected via Hangouts. Let's check something here. Yeah. Meh. Okay, let's try something different, just so that I know that we have somewhat of an audience. Go ahead and shoot me an email. Just reply to the class email, but not to everyone. Just reply directly to me, and I'll just take roll that way. So part of this was going to be a build that on the fly with student feedback, but if we can't get the chat to work, then we'll just do that next time. And this time, I'll just go off on my rant and take notes as we go through. Speaking of which, let me share out my notes screen here. Alright, so it looks like I'm able to share that out with you all. So like I said, just shoot me an email. It's macdiablo@gmail.com. The same email from which, or address from which you've received previous communications. Just loading up my email here. Well, we're about 15 minutes in and I haven't received an email yet, so now I'm just confused as to who's actually here. What's this? Oh, wait a minute. Hey, Patrick's here. How's it going? Well, yeah, I'm going to have to at this point assume that people are at least watching the stream, and if this is just a major miscommunication, we'll pick it up on the second class and go forward. From this point, you're going to have a recording on YouTube of 15 minutes of silliness, so let's just get to the course, and then going forward, you guys can grab the material from the recorded video. We'll just have you start at 15 minutes in, and then go from there. Hey, Harry's here. And Martina's here. Well, that's at least 3 people. 3 of the 20. Alright, I'm just going to start going. So you can't see my face right now, but you can see my Microsoft Word document. So I'm just going to kind of walk you through the document and its purpose. So first up, welcome to the Forensic Workshop. Now, I'm going to talk about what this term cyber forensics means in a moment in case some of you are wondering, because technically there are multiple facets to cyber forensics, but that's down here in the section I have called Realms of Forensics, so we'll get to that coming up. The purpose of today is really going to be about the content. You guys don't want to just sit here and stare at me all day, and no one cares about that. But I will just give you a quick background on what I do. I'm a lead in a security operations center. In fact, let's switch this over to my face here, my smiling face. Hey, so I'm a lead in a security operations center, and what that means is that we have a 24/7 team. We have 3 people on each team, so there's 2 analysts that are on my shift. We have 6 teams of 3, so there's 18 people, and what we do is respond to events within the network. So anomalous activity reported by users, phishing emails reported by users. We also respond to our malware analysis runtime environment that will analyze all the different attachments to email and things that people download from the internet and files that are submitted from the backend, our sandbox that we submit. Shoots off the alerts, and then we field them. So the idea is that you triage, you prioritize, and you take care and you remediate. In many situations, you have a security operations center that simply just looks at the logs like this, just log, 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 log. And if there's something anomalous, they kick it off to the computer incident response team. Luckily, that's not how we operate at my job. So I work for Bechtel Corporation. We're the largest construction company in the United States. One of the top X number in the world. I don't keep track of that. But we build mega projects, multi-billion-dollar projects. And because of that, we have a lot of people interested in our methods and procedures, and for that matter, in our infrastructure. So anyways, the alerts that come in, luckily in our SOC, we handle them. We function as the incident response team. There is a computer incident response team, technically, but they're more of a engineering group, if you will. So they're the ones who maintain, well, implement, install, and then maintain the tools that we utilize. 98% of the stuff we handle. So when it comes to malicious activity, we're the ones that will pull the packet capture, which we're going to be talking about in this course. We're the ones that will carve files out of it. We'll analyze the files forensically, which is kind of what we're going to be doing today and talking about. We're the ones who will hunt down the infections on the host. We'll open up Encase or Google Rapid Response, Mandiant Intelligent Response, many other tools, and try to look and find out what's really going on. So what we're going to do today is talk about some of the different things that are related to how you hunt these things down. So when I first started the video, I have already mentioned this, but I'm going to have you all just skip past the first 15 minutes. So let's just talk about something else first that I've already mentioned. We're going to be building out the curriculum on the fly. So I'm going to be typing as I'm talking. And a big part of doing that is I want to prove to you all that it's not necessarily that you have, you don't need to have, I should say, a big stack of books like these guys over here. So you don't need to have a big stack of books. You don't need to have multi-slide PowerPoint presentations. You don't need to have dissertation papers at your fingertips in order to be able to do what we're going to learn how to do today. You need that background. I'm really big on education. So I got my graduate degree. I highly suggest you all continue through as long as you can in school. But you take that foundation and you have to apply critical thinking to it. So one of my coworkers, who may or may not be on this video right now, Chris, always says, you have analyst in your title, analyze. A lot of times people on my team will be, well, how do I find that out? Go find it out. That's the answer, is go find it out. How do you find it out? Well, it's critical that you have a couple things at your fingertips. One is that you have your brain somewhere in this vicinity, general vicinity here. The other one is that you have Google. If you're a Bing user, log off now. I'm kidding. But I love Google. We all love Google. We find everything via Google, and I'll explain that as we build out our curriculum for today. So speaking of the curriculum, check this out. I'm going to share back the PowerPoint screen, or excuse me, the Word screen. And here are today's concepts. So let me see if I want to blow this up just a little bit more. There we go. Yeah, we've already done that. Who am I? So we're going to talk about the realms of forensics. So this is called a cyber forensics workshop. What is cyber forensics? It's really a vague term. It's thrown around often, but this is me, this is all me, okay? I like to think that it's comprised of 2 primary categories. And this can be debated left and right, but let's go back here and talk about it. Computer forensics involves artifacts that are on a host, whether that host be a desktop, a laptop, a server, whatever, a HNAS store device, network storage, whatever. The idea being, and I do personally, this is personally, I don't want to start a debate right now. Personally, I also include mobile forensics and computer forensics. The idea being, if an employee, for example, has a problem and they get let go, and their cell phone is left behind, and you have to analyze the file system, and you have to gain root access, or you have to jailbreak it on an iPhone to run some forensic utilities, that all falls under computer forensics. So we're not going to be talking about computer forensics today, but I do want to just quickly go into a little more of what that field is about so you have a better understanding. One of the texts that I have for computer forensics is this guy. You see that guy? There we go. Windows Forensics Analysis Toolkit for Windows 7. This is by Carvey. It's another no-start. No, this is Sengress Publishing. Sengress and no-starts are my two favorites. I love them. So this particular text goes over all the different Windows 7 specific based forensic analysis tips. Now, what is Windows or computer forensics? Well, let me give you a good example before I move on. I need to know, this is a scenario by the way, I need to know if a particular user has executed application XYZ. So my boss comes to me and says, hey, we believe that user, whatever, clicked on this application and loaded it. Tell me when, or tell me if that happened, when it happened, what occurred following that, so on and so forth. That is a computer forensics based investigation. In Windows, there are many, many things that occur when a file is executed. So you're going to have your recent runtime, or what's called MRU registry file, which is basically the most recent applications that are accessed. A registry change will be made there. A prefetch file will be created on the system, so well, on a non-server that is, which can be adjusted, but I digress. The prefetch file will load up all the DLLs that in memory and basically create little cache files so that the subsequent executions of the application are faster. So that's just two of, there's like 10 more things. We're not going to go into that today, so I'll just stop there. But computer forensics deals with things that are on the host, and when you watch things like CSI, I love that show because it's just, seems like it's so out there. But when they talk about computer forensics, the funny thing is, although their time frames are completely jacked, you don't find it in 5 seconds. It doesn't work that way. Most of that's possible. So, anyways, we're talking about network forensics. So, what is network forensics? Well, again, there's many texts I have back here that'll tell you what network forensics is. So, in fact, you can pull up Google. In fact, I'm going to Google that right now while we're talking. Let's see, network forensics. Let's see what Wikipedia says. Oh, hey, look. Entire Wikipedia article. I'm going to share my screen here. When I said we're going to build out the curriculum on the fly, I literally meant that. So here we go. Here's my screen. So I found an article on network forensics. Okay, let's read it. Network forensics is a sub-branch of digital forensics relating to the monitoring and analysis of computer network traffic for the purposes of information gathering, legal evidence, or intrusion detection. I like it. I'm going to stop there, by the way. I'm not going to read these wiki articles in entirety because that would be a bit silly. By the way, I'm going to be kind of charting out these notes that I'm taking as we go through, and I will send them, or well, I'm going to pop them on the Google Drive for everyone to take a look at later. So they'll be formatted a little better. But as we go through, I'm just going to randomly find resources, and just to kind of prove a point that when you don't know something, just go look it up. It's really easy. Just go look it up. So anyways, network forensics for us. Let me get back here. There we go. Network forensics for us is looking at what's flowing through the wire. Well, I should say through the network because the network may not be on a wire, but you need to have some way to capture the data and to analyze the data. So I'm not going to get into the whole network design and architecture and whether you're using span ports or taps or however you're capturing your traffic, but I will be getting into once you have the traffic, what do you do with it? In fact, speaking of which, let's take a look and transition back to our little notes screen here, and you'll see the next item I have is packet captures. In order to understand packet captures, you're also going to need to somewhat understand the layers of the OSI model, the Open Systems Interconnect model. And if you're wondering what that is, well, hey, check this out. Let's go right back to Wikipedia and just search for OSI model. Oh, look, there's an article. Cool. We'll just add that to our notes. I'll read the first sentence. Sometimes these wiki articles make no sense, by the way, so let's see how this goes. The Open Systems Interconnection Model is a conceptual model that characterizes and standardizes the internal functions of a communication system by partitioning it into abstraction layers. Yeah, that's a cute way of saying it. Let's do it this way. If you see over on the right-hand side of your screen, I highlighted it. Let me see if that's showing up correctly. That's odd. That window didn't refresh at all. Oh, look what I did. One moment. How many windows? There we go. Sorry about that. I was reading this page. So, let me just put that so I have that in my notes. All right, so on the right-hand side, you see the OSI model. This one's not as graphic as I would like. Let's scroll through here. This one's fine. So, at this point, I was going to ask the students, all of you, to see who is already familiar with the OSI model. But it looks like we can't do live chat, so we'll have to fix that next time. Anyway, the OSI model is comprised of 7 different layers, and if you start down with the very, very bottom layer, let me get to my right window, this guy right here, the physical layer is just a way to kind of visualize. This is all visualization, by the way. Not every network protocol even follows this model, and some networking protocols completely follow their own model, like TCP/IP that has its own separate model. But anyways, the physical layer describes the physical medium over which the traffic is flowing. So a physical layer can be an Ethernet cable. A physical layer can be a fiber optic cable, or it can be the airwaves if you're using 802.11 technology or some other wireless implementation. So then down here, the data link, it says it is reliable, direct point-to-point data connection. So what does that mean? Well, the data link layer really is responsible for traffic flow and organization based on the layer just above physical. So while the physical cable might be Ethernet, the Ethernet protocol and the ARP protocol and things, or address resolution protocol, excuse me, things that function to enable the traffic moving over that physical medium typically appear on the data link layer. The third layer, known as networking, right there, the networking layer is addressing and routing, without which we wouldn't really have networks, because we need to have some type of formal communication for the traffic to flow across. Now, it's at this point here where we're gonna be talking about these guys today. We're gonna primarily be talking about layers 3 through 7. So I'm going to speed this up because I don't want this to be a networking 101 type of thing. In fact, many of you may already be quite familiar with this type of stuff. But the transport layer is responsible for delivery of packets. So I'm not sure if everyone's familiar, but when you load a web page, for example, just google.com, and you type in a search, and it loads up the results, and it grabs images from across the net. While you may have a direct connection to the Google server, by the way, who knows where that is, what cluster you're connecting to, and what data center, I have no idea. And you can find that out, of course, but not necessarily every packet from that connection is going to come from the same place. So the transport layer is the one that's responsible for making sure that they all get reassembled in the correct order on your side of the page. For example, a server cluster can provide maybe, I don't know, 65 servers. I just made that number up out of the Ethereal. I don't know. So, out of the Ethereal? Ether. I'm thinking of the old name of Wireshark, which is Ethereal, which we'll cover later. Sorry. Anyways, so yeah, you can look up TCP/IP. There's a wiki article on that. Moving on. The session layers was responsible for maintaining session communications. So if you're familiar with the TCP handshake of send, SENAC, and the NAC, and the connection that occurs when you basically establish a session with a server, it's actually called a session. It follows the session layer. Moving on, we have the presentation layer and then the application layer. And to give you an idea of what these are, I'm going to scroll back up here. And you see here on the presentation layer, we have some protocols listed that you're probably not familiar with. But if we look at the application layer, we have things you're most likely familiar with. So we have over here DNS, FTP, Simple Mail Transfer Protocol, SNMP, which is the Management of Network Devices, Telnet, DHCP. Most of the protocols you're probably familiar with that are user-based, like if they exist in userland or some type of application where you're going to be clicking or touching something, they're most likely going to be in the application layer. However, we're also very, 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 very reliant on the network layer. Well, every layer is extremely important, of course, but the network layer, because that's where IP lives, whereas TCP, the Transport Control Protocol, lives in the transport layer, whereas the Internet Protocol lives on the network layer. So I'm going to digress at this point and stop talking about the OSI model. Come check out this article. Just run some Google searches for more information. All I want you to understand is that as we're going through Wireshark and some of our other tools, but primarily Wireshark, we're going to be looking at data that's flowing through those various layers, and I want you to understand what their purpose is, and for that matter, why are we looking at it? Why do we care about it? So let's flip back over to our notes. There we go. So we're going to talk about the TCP/IP handshake. So I would ask if anyone's familiar with it, but let's just take a look at it. I'm going to once again share out my random Wikipedia screen. Let's see if we're on the right screen here. Yeah, just no chat. Bloop. All right, we'll close that for now. And close that. And there we go. All right, let's just Google TCP Handshake. Hey, look at that. Bunch of pictures. Let me make sure this is sharing out appropriately. Yeah, you can see my screen. Cool. We have a bunch of pictures here. In fact, I can click images. Well, that might not be safe. Who knows what'll pop up, right? Hopefully we're good here. Okay. So anyway, this one's okay. That one's all right. This one's overly complicated. Just use this one. This is the easiest one to kind of depict what we're talking about. When a session occurs through TCP, which is the Transport Control Protocol, the host will send a SYN for synchronized packet over to a server or to another peer, whatever. And the response is looking for back is SYN ACK. So the ACK is the acknowledgement. So I see you want to synchronize, I acknowledge that. And then the third and final step, is the final ACK coming back from the client to the server, which is just, okay, cool. I acknowledge that you've acknowledged me. It's usually referred to as the three-way handshake. And I'm pretty sure there's a Wikipedia article on it. Well, what's this? iNet daemon. Is this safe? Let's click on it. Oh, yeah, I kind of like this. Here, let's add this to our notes. TCP Handshake. Whoop. There we go. All right, I just want you all to understand that essentially when you're maintaining or connecting via TCP/IP, the protocols in the background, they have an assigned layer, they all have an assigned approach, and they all have an assigned methodology. So most of the time you don't notice that. When you open up a web page and you simply type in google.com, maybe not you, but people who are not familiar with networking in general, they literally think that just the page just shows up. Boom, Google. But of course that's not the way it works. In fact, let's just say I'm on a Windows environment and I type in google.com. Typically what's going to happen is let's see, Windows and Google's what I said, right? I just lost train of thought here. Here's what happens. Your computer looks at its local DNS cache to see if it has DNS entry for google.com. Does it have an IP address to visit? It'll then look for your internal hosts file, which can be configured to flip-flop that, but I digress. There's a file on Windows that'll do name resolution, and it's the resolve.conf, I believe, in Linux, and I can't remember what it is on the Mac OS to save my life right now. And in fact, it's also resolve.conf. So anyways, Unix stuff. Next thing it does, it reaches out to your local DNS device, which is usually provided with your DHCP acknowledgement packet. When your dynamic host configuration protocol will usually send you back your IP address, your subnet, your gateway, and your DNS. So the DNS is usually the gateway. The gateway being, for example, I have, what do I have? Oh, I have Cox Internet. I had to think about that and look at the box for a while. My Cox Internet provider literally has their own DNS server. So if I type in google.com and my computer doesn't know what it is, it's going to reach out to the Cox DNS server and say, hey, what's google.com? And the Cox server is then going to say, well, here's what it is. Let's just say the Cox server didn't know what it was. It would then continue up the chain and continually hit additional higher layer, I guess, DNS servers until it found the answer. If it could not find the answer whatsoever, it's going to hit what's called the root DNS servers. There's 13 of them, A through, what is it, M? Whatever the 13th letter of the alphabet is. I forget what the last one is. And those bad boys are not necessarily authoritative. They don't have the exact response, but they will know where to go. If they don't know where to go, you're not going to get there. So anyways, they'll usually send the response back over to the people who run the servers. Like, they'll know who Google is. Those DNS servers will have their Google DNS servers, which will be authoritative for the answer. The answer then comes all the way back down to you. So while this is, again, a little more networking 101 stuff, when we open up Wireshark, and not necessarily this session, but maybe next session, we're going to need to understand these types of protocols, which is why I'm kind of going into them. Speaking of protocols, if we go look back at our notes, the next thing I want to talk about is HTTP. I want to talk about the request types and the response codes that are associated with HTTP. So this is the point where I would normally ask, who's familiar with Hypertext Transfer Protocol, HTTP? Well, we don't have the chat going, so let's just look it up. We're going to go back to good old Google, and I'm going to type in HTTP. Hey, look at that. There's a wiki article. Of course there is. Let's put this in our notes. Hopefully it's not horrible. Cool. And the first, is that one line? Yep, I'll read the first 2 lines on this bad boy. The Hypertext Transfer Protocol is an application protocol for distributed, collaborative, hypermedia information systems. That didn't tell me anything. HTTP is the foundation of data communications for the World Wide Web. That really didn't teach me anything at all either, so I'm going to digress on this. Ooh, this is a long article. Look at all this. Oh, the history of it. Oh, wow. In fact, actually, here's something important. The next thing I wanted to talk about was request methods, so let's actually do this. I will not read this article. It's too long. But I do want you guys to understand the following. When you open a in fact, let's get visual here. Forget the article for the moment. Hi. So when your browser opens up a request to a server and you are trying to get access to a particular page, typically what's going to happen is you're going to use the protocol, the higher layer protocol, HTTP, and it's going to send a request for the page. Well, how does it send that request? Well, there's various different, in fact, I guess I had the article open, but the request methods that we're going to be concerned with, there's many of them, but I only care about 2 of them, to be honest, for right now. There's a GET and there's a POST. A GET request is a standard browser saying, hey, I want your page. So it just sends off a very well formatted, it follows a very well-known format for HTTP version 1.1, by the way. GET request, G-E-T. And the GET request just says, I want this page. And the server says, okay, here you go. And it gives it to me. When you run a GET request, you can also provide parameters. Those parameters, if provided, will typically show up in the URL bar at the top, right? The address bar at the top of your screen. This is an address bar, apparently. This guy right there. It's on my forehead. I don't know. So that is not secure because, for example, if someone's sitting right next to you, well, if they're sitting right next to you, they're going to see it anyway. But I should say if you have traffic that's captured or if you have some type of mechanism where you're trying to hide data that you want the user to be able to submit, the user is just submitting it in the bar at the top of the screen. So there's nothing very secretive about that. That's another thing that I'm giving a hint toward later. So anyways, another type of request you can make is a POST. A POST request is the opposite of a GET. A GET says, I would like this, whereas a POST says, here you go. Take some stuff. So a POST request, for example, when I'm logging into a page, I typically am going to send my username and password via a POST request. Hopefully it's over SSL, but anyways, a POST request is the user providing data to the server. So when you're in a tool like Wireshark that we're going to be covering very shortly here, you want to look for the difference between GET and POST requests, and I'm going to show you how to visualize even using colors, which is great because I'm colorblind. I had to ask my wife just before this, hey, what color is this? So I know what they are now. So I'm going to show you guys what colors will denote the requests and responses for packets in Wireshark. Okay, going back to our notes here. Oh, yeah, response codes is what I wanted to go over next. So let's see if our wiki article has response codes. I'm pretty sure it does. Oh, it has status codes. That's boring. Okay, I'll share the screen. Why not? Bloop. There you go. All right, so I'm looking at status codes in the article, which is about halfway down in the article, and this isn't the best example of status codes. In fact, let me do a quick scroll. Yeah, that's boring. Okay, someone needs to fluff this part out. But if you look down here at the very bottom portion of this, an HTTP status code is literally just that. It's a code that represents the status of the connection request. So if you are familiar with any status codes, it's most likely a 404. 404 is page not found. So when you're trying to access something that has been removed or something that's no longer there or what have you, you're going to get a 404. Most people are not familiar with an HTTP 200 OK. 200 means OK. It means cool, good, everything worked. And some people are also familiar with, for example, like a 503, a server error. So server errors, specifically a 503, typically denote, the server's not available. So you're probably thinking to yourself, what do you mean it's not available? Well, something may have happened to it. It may have been DDoSed, which means it was attacked and brought down. It may just not be accessible. It may have crashed. It may have too many connections open at a given time, which actually might be also a timeout 501. But anyways. So the response codes are very important, and I'm going to show you in Wireshark how to find out what type of HTTP request was sent. Was it a GET? Was it a POST? I'm also going to show you how to find out what response code came back, and then subsequently what data flowed through the wire or through the network. All right, let's see where we are now. What's this? Ooh, emails. Let me make sure we're good on email here. I'm just checking email to make sure everyone can see. Yeah, I did the individual. Someone just suggested, and I cleared it already, that I invite individually, but I did that through the Hangout. So, well, we'll come up with a better idea for next time. Meh. Okay. So I want to talk about encoding schemes. In fact, do I want to talk about encoding schemes yet? Yeah, I do. Okay. So I want to talk about encoding schemes, or I guess I should say I want to talk about the different ways that you might be able to view data and the ways that data can be stored. So some of you might be familiar with Ascii. Ascii, the American Standard, I already forgot what it stands for, is just what we consider plain text. So if you see a network stream and it just says like actual words that form sentences that you can read easily, that's Ascii. Another way that you might see data represented is the hexadecimal system, which we're going to cover in Wikipedia a little bit. Oh. And you're also going to see some what's called Base64, which is used a lot in web development tools and also for obfuscation. But anyways, let me just let me switch the screen back over and kind of talk to you about this. Is this it? That looks like it. Yeah. All right, I'm going to search for Ascii. Hey, there it is. Wonderful little article on this. So for those of you who may already be familiar with Ascii, let's see. Let me put a little thing here. Again, I'll make these notes look better so that after the course, in a couple hours from now, I'll upload them and you'll be able to view them and we'll be all happy. Okay. So, Ascii is the American Standard Code for Information Interchange. It's a character encoding scheme originally based on the English alphabet that encodes 128 specified characters, the numbers 0 through 9, letters A through Z, lowercase and capital, some basic punctuation, some control codes like turns and new lines, and to 7-bit binary integers. Ooh, fun. In other words, it's plain text English. Cool. Moving on. What else might you see? Well, you might see hexadecimal. And I'll just pop this into our notes here. Put it back there because I like it to be up there. All right, hexadecimal is what's called base 16. So base 16 means the following, and I believe this article has a good example. There it is. Let me make sure I'm sharing out the proper screen. All right, cool. Over on the right-hand side, you can see the decimal equivalent, which is down this. Hopefully, Is it showing my mouse? Let's find out. Yes, it is. Cool. So the decimal equivalent 0, 1, 2, 3, 4. This is what's known as base 10. So hex, however, is base 16. And the way that this works is, as opposed to flipping to a secondary digit after the 9. So if you see here, right, we go 7, 8, 9, and then we move over to what's called the tens place because it's a, what did I just say? Base 10, excuse me. Hexadecimal doesn't do that. There are 16 different representative numbers, well, I should say characters, in hexadecimal. It's 1 through 9, well, technically, excuse me, 0 through 9. And then, instead of flipping over to 2 digits, we then have A, B, C, D, E, F, which represent 10 through 15. So to represent the number 14 in hexadecimal, I would have the letter E. So I'm not going to go into exactly what hex is. That's, if you're not familiar with hex, your homework is to kind of just run some various searches, read through some of this, and get a better feel for what you're looking at. If you're not familiar with hex, we're about to do a crash course in it, so you're going to be all right. Let's see, what other encoding scheme do I want to cover here? Oh, Unicode. Okay, I'll cover Unicode. So Unicode, let me just pop this into our notes here. Unicode is, I'm not reading that. Unicode is an extension of Ascii, if you will, and what it does is it covers more than, what is this, 110,000 characters with 100 scripts and symbols included. Ascii was a 7-bit little convention that was created. Oh, here it is, right here. Where is it? It doesn't really talk about it. So anyways, most Unicode is 16-bit, and what that, well, no, UTF might be 8-bit for any ASCII character, but what we're concerned with is Unicode basically increases the bit length to allow for other languages and other characters to be encoded. So this is all boring. This is some very boring reading. Boring, boring, boring. Here you go. If you look over on the right-hand side of the screen, this that I just highlighted right now, does that show up? Yeah, it does. Cool. This guy right here, these are Unicode characters. So we have pi, no idea, I forgot, and infinity. I forgot what these are. I should know that one, I'm pretty sure. Whatever. So the idea behind Unicode is that we need to encode characters that aren't just English, right? So other languages, other scripts, whether it be kanji or other type of brushstroke-based languages or whatever, they need to have their individual characters recognized and printable on the screen, and so that's what Unicode does. It encodes in those various formats. Often you will see, let's see, we're going to switch this up here. Let's actually, yeah, we'll just go right back over here. There we go, and over here. So for Unicode, you may see information represented as follows. You may see a /U and then some numbers, like that. If you ever see this type of pattern, in fact, if we do this and paste like that, let's make up numbers here. This might represent two different Unicode encoded characters, which is a bit different from hexadecimal, which you can see encoded in a couple different ways. Hex, you might see something like this. You might see that. That's a hexadecimal value. You might also see something like this. You might also see something like this. Let's do this. This is also another way of representing hexadecimal. So there's many ways that you might see it represented, and I'm going to give you a visual on what I'm talking about, a much better visual on what I'm talking about coming up. So essentially, ASCII is for the plain characters in the English language. Unicode is for all language. Well, excuse me, not all languages. That would be nice, but no. But for many more languages, and then Base64 is another encoding methodology that I want to show you guys. Let me switch my screen again. We have a good wiki article on it. Yeah, this is fine. So let me add this to our on-the-fly notes. Just mostly wiki articles thus far. But Base64 was typically, or originated, at least as far as I know, and it looks like Wikipedia agrees with me here, with MIME types. And so it was a binary to text encoding scheme to represent binary data in an ASCII string format by translating it into a radix 64 representation. Oh, cool. What's that mean? Well, it just means silly stuff. It means the following. Check this out. Here we go. This is something I like. We have an example here, a quote from Leviathan. Ooh, that's a classic. Man is blah, 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 blah. This is the ASCII representation of the data taken from Leviathan. So in other words, this little quote right here, right? So how do you represent that in Base64? Well, in Base64, that exact data looks like that. Cool. Okay. So you're going to often see Base64 when looking through packet captures and network traffic. And the reason you're going to see that is because these little suckers, this sucker right here is often used to encode MIME types along with many other things inside various network protocols. So when you're looking at the protocols via tools like Wireshark, you'll typically get a heads up that you're looking at this because you're going to see that what's called padding. Most Base64 ends in an equal sign, or 2, or 3, or 4. So we can take a look at that coming up a little later. I'll show you some real examples. All right, we have one more thing to do. We have one more thing to talk about, which is called file signatures. But you know what? I'm going to get right to the tools. We're going to start having fun now because thus far I've been boring myself. So let's go have fun. Hey, so we're going to get to the fun part now. Hopefully everyone got your tools installed. Excuse me. And you're ready to rock? I'm not sure because I don't have an open forum for easy communication, which is disheartening. But let me share out a couple of my environments so that you all can get a feel for what I'm talking about. I'm going to share out, can I just share everything? Screen, share. Ooh, look at that little matrix thing going on. Let's hide that. Okay, I think you can, yeah. So you can see what I'm looking at now, full screen this. So I use VMware Fusion, which is basically just VMware's, VMware workstation for the Macintosh. My host is a Macintosh operating system. So I just want to show you that typically when you're dealing with forensics or malware or any of this type of stuff, you usually have multiple environments in which you're going to be working. So for virtual machines, I have my Windows 7 domain and non-domain machine. These are for work. Just ignore those. I have Kali Linux, which I use for penetration testing, well, testing penetration testing, because I don't actively go around and black hat things. I also have a malware analysis machine that's running Windows XP. I have something called Rimnux, which is highly recommended if you ever get into reverse engineering malware. It's made by Lenny Zeltzer. He's one of the SANS instructors. So I'll digress on this, but many tools built in for analyzing malware or doing static and dynamic analysis on executables, whether they be Windows or Linux. This is also another Lenny workstation. Rem Workstation is for his SANS Forensics 610 course. I might pop into this, but I'll leave it alone for now. I also have Ubuntu 64-bit, and what's on this screenshot here? GDB. Oh, I was doing some remote debugging apparently. So Ubuntu is one of the more common, or one of the most common, I believe. I think so. Linux operating systems, and I keep a version of 64-bit for various debugging purposes. I also have Ubuntu Server. I don't know why. I was doing something on there. I couldn't even tell you. I have another Windows XP malware VM. You can tell I like malware, malicious software, and playing with it. And then I have another Xubuntu, which is an XFCE, I believe, version, windowing environment version of Ubuntu. We are going to be farting around with Kali Linux. So I'm going to go ahead and boot up Kali now. Oh, it's already booted up. That's handy. I'm not sure if you can see this screen, so let me try it this way. Hopefully you can see this. What is this? Yeah, go away. Alright, so this is one of the environments that I asked you guys to install. I'm currently running Kali Linux 106 64-bit. I'd like feedback on whether or not you can see this when I'm on my second window, but I can't tell. That's annoying. Let me just do something else then. Let me just share out my Kali screen. All right, cool. So hopefully you have Kali available. I also asked you guys to have a Windows VM if possible, and I gave a link to the IE trial machines. They have a 90-day timeout, but it's great for our purposes since we're only going for 6 weeks. And as the equivalent to that, I'm going to open up one of my malware VMs. It's just, when I say malware VM, I mean I just typically use it to review malicious software. That's all I really mean. It's abstracted. And the idea behind this is, oh, I'm sharing out the wrong screen now. The idea behind having a Windows XP machine is that usually it's very susceptible to shenanigans, which is what you want when you're analyzing malware. So here's a quick view of one of my VMs I use to analyze malware. See, I'm getting a note here on Google+. Alright, cool. So anyway, I want to talk about some of the tools of the trade, at least that we're going to be messing around with when it comes to forensic analysis, network forensic analysis. So let's go back and share out my notes. And I'm going to be implementing these tools in the two environments that I just showed you. But here we go, tools of the trade. Oh, I have some of the notes. I'll send you guys these later. But tools of the trade, tool number one is called Wireshark. This is one of the most pivotal tools when it comes to, or most critical tools when it comes to analyzing a packet capture. So I do want to note here that a packet capture is basically data stored from the network that you can analyze later. Like I mentioned, it typically contains information from, well, most of the protocols, the layers of the Osi model. And you can generate a packet capture on your own, or you can open up a packet capture that's been provided to you. So in this particular environment, I gave you guys a packet capture that was in the Google Drive. How many of you got that? Raise your hand. I can't see you. So hopefully you guys got that. Let's see, it's in the Google Drive and it's in the folder I called Levels. And in the Levels folder there is level1.zip. So hopefully you guys were able to check out level1.zip. Let me show you what I'm talking about here. This guy. So this level1.zip file, if you download this, it has an HTML file and a PCAP in it. And the PCAP is what I'd like you to load up right now, if at all possible. That would be awesome. If you cannot load up this PCAP in Wireshark, then just follow along for now, and then when you're done, or when we're done here, you can load it up at some time later. So I'm going to pop into Kali. I'm going to share this screen out, and we're going to go over just a whole bunch of fun stuff in Wireshark. Okay, now before we get into this, if you've never run Wireshark, it's going to look daunting. It's going to look very, whoa, look at all that stuff in there, and oh my goodness. There are many, many resources you have. I think I already showed this one. This is a practical packet analysis. If you have books 24/7, you can get it for free. It's available. The book's not required. The online manual is extensive, but the book does make it a little easier. It's like $35 on Amazon. I popped the link into your notes. But I'd like everyone to launch Wireshark. I don't care where you launch it. I don't care if you launch it in Kali. I don't care if you launch it in Windows. I just launch it. Just have Wireshark running. Oh, by the way, if you're using a Macintosh version of Wireshark, I do care about that. Don't use that. It's horrible. Don't do that. Don't do that to me. Don't do that to yourself. So, anyways, I guess I lied. I do care. I prefer you open it in Kali, but I really don't care where you open it. So I'm going to be going over a lot of things, just random clicking and bringing down menus and adding columns, and you might just be like, it's a lot of stuff. Just watch the video later, follow along. It's fairly easy. It's just going to look daunting at first. I'll say it again. So let me share out my Kali Linux screen. All right, there it is. And you can open Wireshark. I believe it's under Applications, Kali Linux, and I think it's Information Gathering. And where is it? Traffic Analysis, and then Wireshark down here. That's the long way to do it. So there's the screen right there. Kali Linux, Information Gathering, Traffic Analysis, and then Wireshark. Or you can just click up here into your terminal window here, and then just type in Wireshark. If you're running as the root user, you're going to get an error that says, hey, you're running as super user. I had to blah, blah, blah. Whatever. Just click OK. That's fine. So hopefully you have a window similar to mine. And again, if you can't follow along directly, you can follow along later. Just this will all be recorded to, what's that service? YouTube's. So you can just take a look at it later. I'm running Wireshark 1.10.2. Oh, also, by the way, if you're still wondering about where to get Wireshark, in the Google Drive, I have the installer for Wireshark for Windows, and I think I also have the Macintosh version, which I told you to stay away from. I think I put it on there. I should go delete that. But to get it on Linux, you just run, and I guess you want to see the command here. Go back out to the window. That's not it. Where'd you go? I close it? That's weird. There you go. Bloop. And can you see that? Yeah. All right. In Linux, you just simply run. It's available via apt. So you just run sudo apt-get install Wireshark. Really, really easy. And it will go through and say, hey, you sure it's going to take it this much space? And it's going to start to install its dependencies. And then eventually you'll be able to just run Wireshark. And it will work. By the way, if anyone has any questions whatsoever about using Kali, well, not any, all the tools in Kali. No one knows all the tools in Kali. But if you have any questions about getting a particular tool that we're covering now to work in Kali, just shoot me an email. We'll go over it. So let me share back out my Kali Linux. All right, at this point, this is where you want to really start paying attention because we're going to have some fun. So the level 1 PCAP file, I have it in my home directory under Workshop, level 1.pcap. When you open up a packet capture, depending on the size of the packet capture, Wireshark is going to need to parse through all the contents. This packet capture is not too long, although it's not exactly short either. It's what, 16 megabytes or something. So I want to show you guys some various features of Wireshark. And again, as I start to go through, you're going to be like, that's a lot of stuff. Well, it's really easy once you get a better feel for it. So if you've never seen, I'm going to present this as though someone's never seen Wireshark before. Okay? So for those of you that have, just bear with me. Up at the top in our various menus, some of the ones we're going to be quite concerned with are statistics. Actually, mostly statistics, to be honest. We're going to be using statistics quite a bit. Another thing I want you to be familiar with, aside from just having the menus up top, is the ability to right-click. When you right-click on something in Wireshark, it opens up a little window, a contextual window of magic is what I'm going to call it. A lot of Wireshark's functionality is based on these contextual menus, so just a simple right-click will bring up additional options. For example, follow TCP stream is golden. We're going to be talking about that coming up. So you have your menu options up here, but don't forget you can also right-click and do some very powerful things like automatically create filters, which I'll be talking about coming up. So directly under the menu items, you have your little quick access icons, and if you hover over the icon, you get a little tooltip as to what it does. So if you want to record your own session, you can basically use these icons up here. And these icons over here, zoom in and zoom out, so I can make my text larger so you guys can see it a little bit better. Leave it at that one right there. You might notice that my screen looks a little different than yours. Well, that's because I have two columns that are showing that are not standard columns. So the source port here and the destination port here are columns that I made. So what I want to do is I want to give you a better feel for these three portions of the screen: the top part, the middle part, and the bottom part. And then I'm going to show you how to create the columns that I have. So in fact, yeah, I'm going to delete mine and we'll recreate them. So the top part up here shows you all different packets. If you look at the first column, you know what? Yeah, let me remove my column so it doesn't throw you guys off. One moment. In fact, let me just remove these. Okay, our view should be fairly similar at this point. If you just load it up, by the way, the level1.pcap file that was in the zip file that was on Google Drive. So the first thing you see, oh, you know what? Yeah, I'll cover the filters after this. The first thing you see is the number. This is the frame number. These numbers are basically sequential order of activity. Now, keep in mind, activity can be broken up over multiple frames or multiple packets. As such, it's not going to be in chronological order of exactly what, for example, a user saw on the screen. More on that later. The second column is time. This time is the number of milliseconds that actually from the packet capture start. So when you start scrolling down, like I'm going to randomly scroll down here, 171.367914, is that a time that most of you are familiar with? I'm going to go with no, because, I mean, what do we think in milliseconds? No. So if you go over here to view, and you go down to time display format, you get a lot cooler options. One that I like is this guy right here, date and time of day. Click. When I click on that, it gets a little more crowded in here, but if I scroll back up to the top, you'll see my time is 2004-11-04 and then 20:36:36 with some very finite precision timing going on here. But so this is 8:36 p.m. 36 seconds. It gives me a better feel for what's happening here. When you're looking at a forensic case, typically you're going to be following a very specific time format. When you're doing any type of forensic reporting, time is everything. Establishing a timeline is usually one of the most critical things that you need to do in order to, whether you're winning a case or just proving something occurred on your network, you know, whether it's in the courtroom or whether it's in a professional environment and you're just trying to establish exactly what occurred. So, anyways, so again, that was in view, time display format, and then you can change it. So here's an example, seconds since beginning of capture. I can change that to the second since beginning of capture. Cool. That's how many seconds have gone through. I think, by the way, I think I said milliseconds when we first started. Sorry, the default is that one. Whatever. And the next item, these other items, I like UTC format, Universal Coordinated Time. This is my favorite format here. It's always going to give you year, month, day, and then the time over there. So I like that particular format. So I'm going to leave my time like that. It does make your time column a little wider, but that's just fine with me. The next column we have over is source. So when you have communications, you're going to have a source and a destination. So what Wireshark will do for you in some instances is it will resolve the names. It will resolve certain things. So if we look right here, this source is being shown as netgear_CE and then the last few bits of the MAC address. You can turn that on or off. Sometimes I don't like Wireshark to do automatic name resolution for me. It gets a bit annoying sometimes, but I'll digress on that point. Next up, we see our destination. Again, these two go together, and typically you're going to see the alternation of the source and destination. So let's find an example of that. Here's one. Here's a source, a 46.IP, going to a 172 IP. And then down here, you see a 172. Well, actually, that's different. Well, whatever. If that were 55, we'd be golden. But it's something else actually. This is an IRC. This is TCP. Well, let me just scroll down randomly here. And yeah, no good examples. I'll get back to it. We'll cover that later. All right, next up is protocol. So what protocol is being used by this particular network traffic? Wireshark has numerous protocol analyzers. In fact, if you go to Edit and then all the way down to preferences. And then over here under protocols, if you drop this down, this shows you all the protocols that Wireshark is familiar with and is able to decode. Here's one. Look at that. AOL. What? Reassemble AOL messages spanning multiple TCP segments. Cool. So how many does it have? I don't know. It has a freaking lot. So if I scroll through these and randomly stop like that, oh, well, I do know what that one is. I was just going to say I'll probably land on one I've never heard of. I do know what that is. So let's scroll up and click that. Laplink. Yeah, I don't know what that is. Scroll up. Click. GSS API. Yeah, I don't know what that is. How would I find out what that is? Well, the answer there would be Google it. So, not that we need to Google every single protocol, but we just need to be familiar with the fact that it's capable of decoding numerous protocols in our packet captures. So I'm going to click cancel on this window, and once again, if you missed that, that was under Edit, Preferences, and then on the left-hand side, Protocols. So let me add some notes here. Wireshark, Edit, Preferences, Protocols, shows, blah, 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 blah. All right, cool. I'll send those notes out later once again. Anyway, what's next? Next up is length. This is going to be the length of the packet in bytes. And you can change how this is displayed, by the way. But for now, we're going to leave it in bytes. So how much information was flowing through that particular packet? And then over here on the right-hand side, we have info. So this is where Wireshark does its magic. So in here, we see, for example, I'm going to go to frame number 3. When I click on frame number 3, we see info IRCU to NSSTP. And these are TCP/IP flags, push and acknowledge. And then we also have some sequence and window lengths and whatever. So if you're familiar with sliding window, that's what this stuff's about. We're not touching that today. So I want to find out more information. I have this info here, IRCU to NSSTP. What is that? Well, how do we find out? Well, obviously you would just Google it. But I want you all, if you have this open, to right-click anywhere on this line, anywhere on line 3, and take a look at the options you have. You can mark packets, and you can ignore packets. If I ignore a packet, Wireshark just doesn't show that packet any longer. Pretty simple. If I mark a packet, I can mark multiple packets and then run some type of process on whatever I have marked. So it's just, you know, putting a check in the box essentially and then running a command on all that are checked. I can also go down here to apply as filter, and this is where it gets amazing. If I want to only look at a certain type of traffic, or I only want to look at traffic from or to a certain address, I simply right-click and I choose apply as filter, selected. Now what I just did right now created what's called a filter. And if you look up here at the top left-hand side, right there, I'm highlighting it and moving my mouse erratically so that it draws your eye over to it. I have a filter set right now, and this is one of the next things I want to talk about. Oh, look at that. We have a tooltip that tells us exactly what a filter does. Cool. That's pretty cool, actually. I like that. So Wireshark has its own filtering language. An example of a filter being applied is IP.dst, which stands for IP destination, and then we have equals equals. So I know some of you have a programming background. This is not an equals, it's an equals equals. Huh? And then the IP address. So this is telling Wireshark, hey, filter out everything where the destination is not basically this. So I'm telling it I only want when this is the destination. Right? Now, filters are very, very cool and can be very complicated. So if I click clear, that filter goes away and I once again see all of my traffic. Okay? I want everyone to scroll down to the very, very bottom of this in the Wireshark window. And down here on, well, what is this, 20883, you're going to see the protocol SNMP, Simple Network Management Protocol. If you right-click on this, right-click on where it says SNMP and put Apply as Filter Selected, oh, it tells you to go away. Well, whatever. Why doesn't that work? I don't know. I've wanted to know that for a long freaking time. But what I do know is, let's say I want only SNMP traffic. I go up here to filter, and guess what I type in? It's really simple. SNMP. Enter. So why can't I right-click and do it? I don't know. Someone find out and let me know. But by simply typing in SNMP, it filters on this traffic. So I can scroll up and down through this entire thing, and out of all these frames, these are all the SNMP traffic packets that were captured. The section directly below this portion right here gives much more detailed information. So I can see information based by frame. If I click on that, I see frame information. We're not going that deep today. We'll just collapse that. We can see Ethernet. So not only did it come on a frame, but it was an Ethernet frame. Below that, I can see Internet Protocol version 4. And I see here the source and destination. When I click on these things, you'll notice in the window below, the third portion down here, this is the actual data that actually flowed across the wire, if you will. So when I click on these, this is the data that the network is sending. So for example, that @ sign right there, what does that @ sign mean? Well, it means don't fragment. Well, technically it means that the flags were set based on that value, which that value means don't fragment. There's 3 flags that could have been set using those 2 bits, but whatever. We'll come back to that. That's 2 bytes, excuse me. Sorry. I know Chris just lost his mind there. Anyway. So you have your header checksum. You have all these fun things down here. Whatever. I'm going to collapse this for now. Down here, you finally have the protocol itself that's been decoded. So Wireshark knows, hey, this is SNMP traffic. Cool. What's in it? Expand it. Here's one thing. Community is public. If you have a chance, go look up SNMP community public and see what that means. You'd be surprised at what you might find in your enterprise or even your schools. I'll cancel that last part. Don't check your school's network with Wireshark. Sorry. Network. So I'm going to back off the SNMP, and up here under the filter, I'm going to click clear. If you'd like to cheat when it comes to filters, and I often like to cheat when it comes to filters, just to the right of the filter that you have here, you can click on expression. When you click expression, you can then choose all these different saved filters that already exist. So for example, I'm going to cheat and I'm going to find HTTP. Let's see, can I just type it in? I can, cool. There's HTTP, drop it down. Here are the various filters that Wireshark recognizes for HTTP. There we go, make that window a little bigger. So if you remember earlier, we were talking about request types. Well, if I click right here, HTTP request method, I then have in the middle is present, equals something, does not equal something, and then the greater than, equals, contains, matches, so on and so forth. I'm going to make it is present and press OK. And you'll see that what this does now is it changes the filter to HTTP request method. When I hit enter, it filters my traffic to traffic that involves some type of HTTP request method. You'll see over here under info that most of the items I have are GET requests. So we're going to delve into one of these GET requests, but before I do that, I want to show you all the following. We're going to talk a little bit about filters, just real quick, because they're very powerful, very versatile, and something you're going to be using often. Okay. So, Wireshark Filters. This takes you directly to this link that I found here randomly. It takes you to wiki.wireshark.org, which is the online documentation I was talking about that's ridiculously powerful. So, I think I just said powerful like 5 times in a row. Whatever, we'll be okay. Alright, there's the link, display filters. This link here on the online documentation gives you some examples. So, alright, request URI. I can look to see if there are specific characters in the Uniform Resource Identifier. In other words, up in the address bar up there. This one's going to be a little more complicated. This one is saying I don't want a particular... Let's see, am I sharing this out properly? Yes, I am. This one is saying I don't want this source address, and obviously you'd want an address there. And you can do some concatenation, or not concatenation, but I should say some combinations here. I also don't want that destination but then I also only want SIP traffic, which is typically related to telephony, and you'll have to look that up if you're not familiar with it. So you can combine these bad boys, and this is fairly short, but you can go into the user's guide and get much more advanced information on this. And again, don't forget that when you're in Wireshark, and let me go back over and share back the screen. There we go. When you're in Wireshark, you can typically just cheat by right-clicking and then choosing to follow. So what I want to do right now is I want you to find any GET request. I don't care how you find it, just find it. So in fact, if you just scroll down and then look for the word GET, cool, whatever. I don't care how you find it, just pick one. I'm going to make mine http.request.method. I'm just going to filter on http.request.method. That's it. And then I'm going to talk about what you can do in Wireshark as far as following information that's flown through the wire. It flown. You right-click and choose this guy right here. It says Follow TCP Stream. This is one of the more powerful features of Wireshark, and what this does is it allows you to follow the traffic as it occurred. The top part, which I've just found out, is red, by the way, and the bottom part show the request. This is the original GET request, and this is the response. The blue portion is the response. So you'll see up here that it was a GET request. The host was google.com, and it was searching for dollar bill y'all sloth, which, by the way, be very careful in looking that up because there's some questionable content on Google Images and other places, so heads up on that. I should mention that the challenge that I'm going to provide to you guys has some questionable content, so if you're easily offended by language or, for that matter, partial nudity, please let me know before you delve too much further into this packet capture. This is all meant to, well, basically, this is a real-world type of examination. In the real world, when you're doing a forensic investigation, some of the stuff that you come across will make your head spin. So there's some geek humor implemented in here, and there's also some of the stuff that you're going to find in many investigations. So if these kind of things might offend you, then please let me know, and I'll also mention that in a more formalized manner. In fact, it's in the rules for the contest or the challenge we're going to be going through. It's not a contest, excuse me, it's just a challenge. All right, anyways, the user agent shows exactly what type of device is connecting. These are the MIME types that are going to be sent back and forth. The encoding, gzip, typically web pages are actually sent in a zipped format and extracted on the fly. It's kind of a funny thing the browsers do. And then any cookie data, which is basically persistence data, will be shown here. The response. Remember we were talking about the response codes, and I believe Chris actually posted in the Google Plus Hangout area a link to some actual response codes. I'll have some more information also in your notes when I upload it to Drive later on today. So we got, for our GET request, we got a response saying 200 OK. So for response codes, 200 means good, you're good to go. The next thing we have is the date and time where it occurred. The connection expires, -1, never. It never expires. And then I don't care about that. Content type is text/HTML. So you're about to get HTML, and again, it's typically gzipped encoded. And then following that, you don't see anything else. Well, that's because it opens up another connection that actually sends some information. But one thing I want you to notice is, what are we looking at right now? We're looking at a Google search. What was the search for? Well, it was for that right there. But what does that tell you? It tells you a couple different things. In network forensic analysis, you can often find things like Google searches or Bing searches or any type of search for that matter. Sometimes you'll see the individual Google results that'll even pop up as the user is typing in the search. If you're familiar with the automatic searching, the real-time searching that Google does, you'll even see that. So kind of see how the user types in his or her request, which would be kind of eerie sometimes. All right, let's see. We went over display filters, went over right click, follow TCP. Oh, I'd also like to go over searching. So to search in Wireshark, you just go to Edit and Find Packet. It's just Control F, by the way. Edit, Find Packet brings up this window here. Making it full screen is not pretty, so I'm going to leave it as a window. I'll just put it here in the. I'll put it right in the middle. So you can search by display filter. You can search by a hexadecimal value, and you can search by a string. Typically, we're going to search by string. So in here, you can also designate whether you want to search via the packet listing, the details of the packet, which are over here, or the actual bytes in the packet. If we want to search for a particular word, we are usually going to want to search string packet bytes. And then be very careful for this, up and down. It is direction based. It will wrap, however, so I usually leave it on down. And I can search. So if I want to search for the word Bob, hit find. The first thing it did is it found, remember, we're looking at the bytes of the packet. Did I actually find the name Bob? No, I just happened to find BOB, which in hex is 42.4F42. So you can search again by going to find next or doing Control N. So Bob is not a very good search term. I'm just hitting Control N. There's something. Technabob.com. Someone went to technabob.com. Okay, I had no idea what technabob.com is, but someone did a standard DNS query for it, so they were hitting technabob.com. All right, let's search for something a little more useful. Let's search for the word meeting. Nothing. Bottom left-hand side down here, no packet contain that string in it. And it's ASCII converted, blah, 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 blah. So you can get a little more information, by the way, by expanding and closing these down here. All right, why don't I search for meeting? Well, often when you're doing a forensic analysis, you're going to be asked to find certain types of data, like when did someone meet so-and-so, or who is someone talking to? So if I say, who's Ryan talking to? I need you to find this information in this packet capture. Well, how do I find that? Well, one thing I would probably want to do is I would probably want to do a string search on the packet bytes, and I would want to type in meeting, or I'd want to type in Ryan. I don't think that's in this. No, it's not. So, but of course, if I type in Google, well, then I'll find that right away. And let's just say I hit this guy, and I'm thinking, all right, what really transpired here? If you remember, the way to find it is to right-click and go to Follow TCP Stream. Bam. Let's open this up. What is this? It's a GET request. GET request for what? I don't know, something from Tumblr. Oh, okay. So another dollar bill y'all sloth and media Tumblr. So it's a picture on Tumblr possibly. What's it end in? Nothing. What's the content type? Just text HTML. It was referred from here. Whenever you see refer is the site that sent the user to that particular place. So this JPG here, that guy right there from Tumblr, was actually referenced by this search here. So it looks like an actual Google search just sent them over that way. So pretty simple. What's the response? 200 OK. Okay, well that's the response. What came back? Well, there's some HTML here. So this is a divider with a weird ID. There's the ID of the divider. If you're familiar with HTML, you can read through this and find out what it does. This is just a labeled divider. I'm pretty sure the divider is filled with something in subsequent TCP communications. So I'm going to close this for now. All right, another thing you can use Wireshark for, which is very handy, is exporting objects. Wireshark is able to recognize various types of objects. So I can go over here to File, Export Objects, and then I can pick HTTP or small message blocking, which is basically like file shares. DICOM is some weird medical protocol. I have no idea why it's even there. It's pretty odd that it is in my mind, but whatever. So maybe it's used for something I'm not familiar with. That could be it. But if I go to Export Objects, HTTP, this gives me the ability to look at all the different objects that came down via HTTP. you can't sort these, at least in my version of Wireshark, which I think is ridiculous. But there are other tools that will allow us to cheat and do this, so whatever. Under content type, I can see that that's a PNG, portable network graphic. This guy's right here, cascading style sheet. This guy is a JavaScript file right there, embed.javascript, and so on and so forth. So I can export one of these if I want. Let's see, do I want to export something? I do. What do I want to export? I don't know. Let's just scroll down randomly and click on... These are boring. Where's a picture of a sloth? I'm sure there's one in here. JavaScript. Let's pick an image. Here's weird images. I don't know what these are. I'm not sure if I should export one. Let's export this one right here. I can click Save As down here at the bottom right-hand side, and then I can save it. So I'm going to save it to my workshop folder. Whoa, what? No, do over. Alright, I saved it as blah.jpg. Let's go see what it is. Come on. Oh, there you go. Ah, it's a picture. It says know your meme. So it looks like when they were searching for that dollar bill y'all sloth, they came across the picture for know your meme. Cool. I think it's a website that catalogs memes and their origins and such. I think. I don't know. I might have just made that up. I couldn't tell you. Alright, so that's how you export objects. Now, why is exporting objects handy? Well, it's handy because you don't have to carve out manually a file if you use that particular method. However, I want to show you how to carve, well, not carve a file, but how to easily obtain a file. So if you go over here to length, I want you to sort by length. Sort by length of the packets. And then we'll scroll up here. Well, these are long. Maybe that was a bad idea. Let me find a better way. What's this? Yeah, I want this. Alright, another way to do this. Everyone go to frame 7360, which, by the way, is in TCP stream 240. So TCP.stream EQ for equals 240 is the filter you can apply. And that'll bring up this particular series or sequences. Is this what I want? Yeah, this will work. So just scroll down to 7360. So if you don't have anything set, just sort back by number and then just scroll down to 7360. It's an HTTP 200 response for a JPEG. If you don't see this particular one, I don't care which one you find, just find a 200 OK for a JPEG. But go to 7360 if you're able to do so. Right click and go to follow TCP stream. And you're going to see the following. Up at the top, we have a GET request for a JPEG. Joint Photograph Expert Group. From where? This is actually a content provider for Facebook, CDN. You're going to see them often. They basically host all the content for the larger sites, and it can be very annoying. Anyways. So the referrer to this was this guy right here. So some random big Facebook post, facebook.com cheeseburger. Uh-oh, it's going to be something stupid. And, oh, there you go, knowyourmeme.com. Okay, the response back is, okay, the content type is image JPEG. However, what do you see in here? You actually see this content start with JFIF. That's what's known as a file signature. So what I want to do now is kind of talk about file signatures briefly. To do that, I'm going to switch my screen. Hey. So a file signature is what the operating system uses to determine how to handle a file. So if I just Google file signatures, the first link that typically comes up, let me make sure, yeah, this guy right here. GaryKessler.net. His page is absolutely amazing. I save it to PDF once a month. It's a must at our place of business. There's also this filesignatures.net. They have a pretty extensive library also. But I'm going to click on File Signatures, Gary Kessler. And if I start to scroll down, I start to see some file signatures. I see the hexadecimal signature. I'm just going to scroll down a little bit. Here we go. Here's one. Here's the signature in hex. Here's what it will look like when you're looking at it in Ascii. So what's this signature for? It's for an MP4 file. So motion picture expert group, layer 4, MP4. You guys are familiar with that particular video container, most likely. So if you ever see an Ascii FTYP, it's most likely an MPEG movie. Well, this is a long list. Luckily, we can search the page. And on a Mac, it's Command F. On a PC, it's Control F. Wherever you are, you can probably know how to search your own page. So what did we see over here in this capture? We see JFIF. What is that? Let's find out. JFIF. Hey, look at that. It says here JFIF has an association with a JPEG, which is exactly what we're looking at. So that makes sense. These are the hexadecimal values you'll see for a JPEG. Now, if I wanted to save this particular file, how would I do that? Well, here's one trick. Down at the bottom of the screen, we have viewing options. We can view the entire conversation, which will be the GET request and the response. Or we can view one or the other. So if I choose this is just the user requests. And if I choose this is just the response back from the server, which unfortunately cuts off the bottom. This is Wireshark is failing us right now. That sucks. Oh, Wireshark is chunking this. This is a horrible example. Well, anyways, let's just talk about file signatures a little more here. We know that it's a JPEG because we see the file signature in here. So I'm going to show you something really quickly to save a lot of time. I'm going to switch over to my malware XPVM. And I'm going to run something called Network Miner, which is going to require me to change my screen. There we go. So right now we're in Network Miner. And I changed my screen there. Hold on. There we go. So if you open up Network Miner, it loads up. And you have an option to File, Open. What is it going to open? It can open PCAPs or dumps or logs. I am going to open up the level 1 PCAP. Let me copy it over real quick. And just drag it into Network Miner. You'll see that Network Miner is starting to parse through this packet capture. Up here we have hosts, frames, files, images, messages, credentials, wait a minute, sessions, DNS, parameters. It's loading all this information. It's showing us all the various communications that occurred in this PCAP, and it's showing it in a much more readily digestible format. So for example, someone went to secure-us.blah blah world running on a Linux server. If I drop this down, there's the host name. It's running on Linux. Why? Well, Ettercap tells us it's Linux. It's a passive OS fingerprinting tech stuff. We'll go over that later. How many packets were sent? How many were received? And all this other stuff. It's very easy to view in Network Miner. I don't want to spend the whole class talking about Network Miner. What I do want to do is I want to show you something. If you click on Files, Network Miner has extracted all of these different files already for us. In fact, we can sort by extension. And we can see that we have some certificates, some CSS, some GIF files, some JPEGs, some JavaScript, more JPEGs. I'm going to right-click on this JPEG and go to Open File. Oh, look, there's a dollar bill, y'all sloth. This came out of that PCAP. Now, we could have manually carved it out, which I'm going to talk a little bit more about next time. Or we can use something like Network Miner and just kind of cheat. One thing I need to give you a heads up on when it comes to Network Miner, when you run Network Miner, these are all the things that came out of this PCAP, by the way. When you run, hopefully this is all appropriate, when you run Network Miner, it's going to automatically extract everything to your hard drive. So take a look here. It puts it in the Network Miner folder, which I'm running an older version. That should technically be 161. I forgot to upgrade before this stream. That's fine. Assembled files, the address from whence it came. I don't know. Can't make that word up. And then the protocol, and then bam, your files. So here's a dog. Says he has no idea what he's doing. Okay. What else do we have here? Oh, little Oregon Trail reference, huh? Remember that game? Oh, more Oregon Trail. Cool. And there's our, whoop. Oh, that's okay. An owl who's bawling hard. All right. Anyway, so this is a kind of a cheap method to grab information out of a packet capture. Alright, so I'm going to close up Network Miner. On your own, please experiment with Network Miner. It's fun. Take a look at it. Play around with it. What I want to do right now, though, is I want to talk about Hex Editors. Every once in a while, we need to pull information out of a PCAP, and we need to analyze it. So whether you pull it out using Network Miner, or whether you pull it out manually, I want you guys to take a look over here. I'm going to open up one called HXD. I don't care what you guys use for a hex editor. Whatever you use, I'll be able to give you some assistance with it. HXD is one that's available for free. It's fairly common. It's fairly popular. I prefer one called O&O editor, but this is paid software, so I won't cover it. It has a lot more features, but whatever, who cares? So what I'm going to do right now is I want to go take a look at, not that, I want to take a look at, let's see, let's grab a file that was just disassembled. So let's go here. No. Yes. Yes. And let's sort by date. All right, grab one of these, grab one of these, grab one of these, grab one of these. Oh, there's no pictures in there. Go over. Well, all right. Let me just open it back up. I'm going to grab a picture, but I'd like you guys to just go Google a picture. I don't care what it is. Go Google something appropriate, inappropriate, whatever. So let's find a picture. Boxer dog. I have a boxer. I like dogs. I like boxer dogs. I'm going to go to images. Oh, this one looks sad like my dog. View image, and I'm going to save it to my desktop. I'm going to copy it. As I close my windows, get them out of the way. All right, here we go. I'm going to copy it over here. All right, in fact, forget Network Miner. I'm going to open up this picture in this hex editor. When I open it up, you'll notice this is Ascii over here, and this is hexadecimal over here. Now, if you remember me talking about file signatures, let me make sure that we're looking at the right place, or that I'm showing my window correctly. Cool, I am. Good. So Yoya, it looks like it says Yoya, and then JFIF over here. So what is this? Well, if you go over to the file signatures page, you'll find out it's a JPEG. Well, of course it's a JPEG. It's the dog. It's the boxer picture that I downloaded. There it is. Oh. If I go on here and I delete this, let me copy this first before I do this. I'm going to delete that. Save it. Close it. Open it. Fail. It doesn't know how to handle the file anymore. Why? Well, aside from me randomly deleting stuff from the file, what's happening is I'm removing a very pivotal part of the file that the operating system requires to know how to handle it. Every application that gets installed, or sometimes upon runtime, they'll add an entry to the registry, at least in Windows, that tells Windows what type of files, the class of files it's able to handle. And so those file signatures that it parses, that usually at the very beginning of the file, you can find those on the web like we found. And so when you pull up a file in a hex editor and you look at the different file signatures, you'll be able to tell what it is. All right, I'm gonna move back over to my notes. We're getting close to our time here. I covered Wireshark, Hex Editors, and network miner. And then we have data conversion, and then our challenge. So we got 15 minutes, we're good. So data converters. I do want to talk about methods to convert data. Now, when you find data in a packet capture, and how do you find data in a packet capture? Well, it's pretty easy. We were going over that. Let me open up Wireshark on here. I think Wireshark, yeah. Hold on. Here you go. Here's Wireshark on my Windows XP machine. So now we're no longer in Linux, but we're in Windows XP. And you'll see that it looks very similar. So if I'm in here and I right click and I go to follow TCP stream. Whoops, ignore that. I right click and I go to follow TCP stream. There we go. And what is this for? This is a GET request. What's coming back? gzip information, text HTML. Doesn't look like text HTML to me. What is this? What's this big thing? It's a big chunk of something. It ends in I end. Oh, that's the start of here. By the way, here's a file that's contained in here. The file signature is PNG. Take a stab, just take a guess there at what that might be. PNG is exactly what you think it is. It's a picture. Portable network graphic. This is the file signature. How do I save this? Well, I can do a save as, and I can save it to my desktop. If I do a save as to my desktop, I can then open it in a hex editor. When I open it in a hex editor, I have all that information from that entire stream is in here. So there's all this different stuff in here, right? But if I search for PNG, there's the first request to it. Find again is F3 in this particular one. Keep going. Oh, hey, look at this. PNG. I find this part right here by just going to save. And once again, I was in follow stream. I saved the entire thing, right? And I click Save As, and I saved it. An easier way would just be to individually go to File, Export Object, HTTP, but that's boring. I don't want to do that. That's silly. So in here, I want this portable network graphic right here. This is the one I want. All right, it also has an IHDR. Well, if you go look up the format, or what am I trying to say, the structure, I guess, of a PNG file, you will see that you're going to get the an I header, which basically gives, it's kind of like the EXIF. No, it's not EXIF, but it's the information based on the utility that created it and stuff like that. And at the end of it, you'll notice that there's actually an I end, which ends the structure itself. Okay, well, I want to pull that out from here. So how do I pull that out from here? Well, the first thing is you have to make sure you know what actually starts the file signature. So the file signature here, let's do a search for PNG. All right, there it is. The file signature is %, well, in ASCII, it's this right here. All right, what is that in hex? Because you always want to edit the hex, not the ASCII. You see the hex value, it starts with 8954E. So, oh, there it is, 8954E. So it literally starts right here. So I take everything above this, and I delete it. And then I just scroll down a little bit. Where does it end? I don't know. How do I know where it ends? I don't know what to do. Well, here's what you do. It's fairly easy. If you remember down here, when we're looking at these, they typically end where it's literally saying I end. So let's just do a search for I end. There's the I end right there. And then here is a GET request. Another GET request following that. So let's take this GET request here, toss the whole thing. So now we have some PNG file that we randomly grabbed. Let's see if I grabbed 2 on accident. No, I grabbed 1. So I have the header is correct. This is called file carving, by the way. We're pulling this file out manually. Now, is this the proper place to cut at the end? I don't know. How do you know? Well, you find out by going to Gary Kessler's site. well, to any site that has these, but I really like his site. So let me do this real quick. Check it out. On his site, it says, here's the header, and by the way, here's the trailer. So the trailer is the end portion of this. So I need it to end in 426082. Now, if we go back, keep switching so many screens. Is that the guy? Let's find out. Is that it? Yeah. Hey, look what ours ends in. It ends in 426082. I just so happen to have cut that in the exact proper place. That's not common, by the way. I figured I was going to have to remove some of this, but I don't. At least I don't think I do. Let's find out. So I want to save this file and then close it. So remember, I just took this entire stream and I cut it based on the file signature. And I'm going to go, where is it? It is ASDF, and I'm going to name it .png and open it, and there it is. We just carved out this image. What is this image? It looks like various things that are used for Google. So Google has, this is like what's an image mapping that Google just cuts out the code and uses the various pictures from it. But this is a complete portable network graphic that we just carved out of that packet capture. So here's our PNG. How did we do that? Well, we simply saved the whole darn thing. We opened it in a Hex Editor, and we started with the GET request, and we just did a find, and we found where it started. That's not it. F3, search again. That's not it. F3, search again. Until we got to this. Gary Kessler's site says that's what starts the file, so we deleted what's above it. What does it normally end with? It ends with IEND. There's the IEND. So then we took the other part. Anyways, you see what we did. So that's how you carve that file out. Or you can use Network Miner and just cheat. Just go to Files, just cheat about it. Or you can use Wireshark. Let's see, go away. And go to File, Export, Objects, HTTP. All right, so we talked about a little bit about file carving. Let's talk about data conversion real quick. If you have something that you find and it's in hexadecimal and you would like it to be in another format, there are multiple tools that you can use. One tool is a tool I gave you called Converter. It's in the Google Drive. It's made by Kahoo Security. Those guys are geniuses. I freaking love what they bring to the table. Up here, this is input and this is output down at the bottom. I can say, hello class. I can then convert these. So what do I have? I have text. What do I want to convert it to? Let's convert it to Base64. So I click right here. Text to Base64. That's my Base64 encoding. And if I want, I can put that up here, and I can put Base64 to text, and it converts it right back for me. So I want you guys to kind of play with Converter on your own. I'd prefer that you fart around with this on your own. But I want to show another way to do this. Another way is via Python. Actually, there's two other ways I want to show you. One is via Python, and one's an online thing. And then we'll get to the challenge and get this show on the road here. So where am I? I'm going to go back into Kali Linux, which is not showing for me for some reason. Kali share. You type in Python and you get Python. One cool thing about Python is you can literally just use it as a calculator replacement. But what I want to show you right now is a way to convert Base64 in Kali. You can do import Base64, and then you can do Base64.B64 decode, and then your Base64 goes here. Which, don't forget, Base64 often ends in an equal sign. All right, so another way, by the way, that's the decode. You can use an encode in Python also. So to find this information, you would just go to Google. In fact, I think I think I have the internet working through Kali. I do believe. Oops. Python Base64. Hey, there we go. And I click this guy, and here are the various things that you can do with Python's Base64 library. So here's the encode and decode, and you just add a string, and then there you go. Another thing I want to show you is Base64 Encode online. There are many different online encoders. I want to quickly mention you have to be very careful for operational security. You don't want to put sensitive stuff out on the internet. So you don't want to have a situation where you're taking your company's info and what might, someone's attacking your company, but you put that information on the internet by decoding or encoding on the internet. You don't normally want to do that. But let's just say I put hello world. This session is just about over. And I encode it. I get this. This is my Base64. Am I sharing this? Wait a minute. Yeah, I am. And I get this. I take that into Python and I paste it in. So we have in Python import Base64. We run Base64.b64 decode and our string, bam, and we run it. Hello world. This session is just about over. So for Base64 and for hexadecimal, you have the converter Windows application, or you can just use Python. And another homework assignment for you guys would be basically just find out how to decode and or encode hex using Python. I'll put that in our class notes. But finally, I have like 2 minutes here. I'd like to show you guys the challenge that I've proposed. The challenge is a borrowed resource, but I've edited things. There are some things in there that may be a bit odd for you. So again, if you're easily offended, please let me know. And I want to show you something real quick before this thing just closes on me. All right, the challenge. I think I'm still sharing out my Kali screen, hopefully. Time is ticking. Yeah, it is. Okay, cool. So the challenge has a zip file. Oh, that's right. Forgot about that. In the zip file, you're going to see level1.html. What? Come on, dude. And the level 1 HTML tells you your task. So this challenge is all about fun. I just want you guys to read through the task, and then basically you just have to search through the level 1 PCAP to find the answer to this question right here. So I'll let you read through that on your own. There's also a rules file that I put on Google Drive. Hey, come here. The rules file shows you the rules of the challenge. It gives you a little setup and a little breakdown. Basically, it says the following. Go through level 1, try to find the answer. When you think you found the answer, email me directly, personally. Don't spam everyone. Email me. You can't just run strings. You're going to have to do a little more than that to find these answers, okay? But make sure to search through the PCAPs and do everything you can in Wireshark. Look for some resources. So this is just for fun. The homework is to try to get through level 1. If you get the correct answer to level 1, I am going to shoot you the password to the TrueCrypt container for level 2. So you can install TrueCrypt in Linux, you can install it in Windows, the Mac. You just go down here and click Select File, choose the level 2 TrueCrypt file, and then when you hit Mount, you'll have to put in the password. Don't try to brute force this password. You will not succeed. Trust me. Anyways, when you think you have the answer to level 1, shoot me an email, and we'll talk otherwise. So pretty much that wraps up the first day's session. Just at the 2-hour mark, so if you're going to watch this later, well, it just cut over 2 hours. It's going to cut me off now. But I don't want to go too much longer since that's our allotted time. Take a look at the challenge, read the rules.html, which is in the Google Drive, and open it in Wireshark. Use Network Miner as your last resort if possible. Remember to get files out. You can use Wireshark file export. You can also use Network Miner. And you can also use the manual method of right-clicking and then viewing the stream. Pay attention to file signatures. Search for anything that may seem relevant. So when you open the level1.html, like search for anything that's in there. It might give you some hints. So you're going to be dealing with various protocols and searching through. Right-click, follow TCP stream. For that matter, right-click, follow UDP stream. Oh, you know what? I lied. I'm going to take 3 more minutes here. One more thing in Wireshark. One more very important thing in Wireshark. When you load a packet capture, one thing that's very important is under statistics, protocol hierarchy. Sorry, I meant to show this. We'll go over a couple minutes over. We're all going to live here. When you look in here, this will show you the various protocols that were used. So here's my SNMP stuff. Here's some JPEG files that were transferred. Here's some internet relay chat. Here's some address resolution protocol. You can filter on all this stuff. So for example, if I want to filter on NetBIOS, I right-click, apply as filtered, select it. And then I can right-click and follow the UDP stream. So, mail server file, what's going on there? I don't know. So, again, statistics, protocol hierarchy. Another very important thing is statistics conversations. Conversations will show you the various endpoints that are communicating. So if I have it on Ethernet, I see the devices that are communicating. I can also go to IPv4 and see all the IP addresses that are communicating. There's quite a few in this capture. So yeah, remember statistics, protocol hierarchy. We will get more into Wireshark in the next session. And again, the homework is to, one of them was, what is it, encode and decode hex using Python if you're able to do so. But also just to open up the level 1 file, take a look at the rules also and see how far you can get. Alright, that's it for the first session. I'll see you guys back here. I might use this medium or a different medium. I'm not really sold on this one at this point. So I'll see you guys back here next Friday at 8 a.m. Cool. Email me if you have any questions. Alright.